What do we got? Number 2. 2 multiple choice? Sorry, I went way too far. What do you guys see? Because I need to work with what your brain is seeing. Because remember, I've been speaking this language for a while. What do you see? U sub? Straight U sub? What do I mean by straight U sub? Straight U sub says look at the denominator and see if there's anybody inside, right? Okay, so straight U sub would say, okay, U is equal to 2y minus 3y squared. Is this a good or bad idea? I don't know, unless you do. Du. Unless you do du, right? Take the derivative. So 2 minus 6y, oh dear, 6y. Why am I getting on a lot of you guys that are not writing dx for those of you that are coming and showing me your work? Because A, you might have missed some check marks on your FRQs because you're not writing dx or dt or dy. But B, what do you need to remember to do next? Get dx by itself. U sub. Remember? Now we sub. We don't sub until we have both the u and the dx. I just crossed it out, but you guys know what I mean, right? Until we have the u and until we have the dx. Why? Well, you got the u from somewhere. So hopefully you can plug him in where you got him from. And the d, well, okay, in this case it's a dy, I suppose, right? So that's a little illegal. I would have probably gotten a check cross if it was an FRQ, but now I have it all better. Go plug in for the dy, and I get du over 2 minus 6y. Guys, was this a good idea? Yes or no? Oh, yeah, because what can I pull out of this? 2. And if I pull, what am I technically pulling out? Good, good, good. I just wanted to make sure you knew it. I'm pulling out a 2 from the denominator. Now I'm going to end up with a 1 minus 3y times 1 minus 3y, right? I have a du, and what am I going to do with this square root of u do? ln, of course. Look at the, no. ln is 1 over u, not 1 over square root of u. What do I hope you would do? Rewrite. Now antiderive, and you should be just fine. Yeah? Because now we add 1, which is going to be 1/2 power. We divide by 1/2. And guess what happens to our 1/2s? They reduce, so all we have to do is actually plug it in, plug it in. If worse comes to very, 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 very worse, what could you do to solve this backwards? Derive, 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 derive. Figure out which one matches. Dangerous. Will take so much more time, but worse comes to worse. What else do we have? 5. I like it. Can I give you guys a hint in AB? That you will probably not receive anywhere else because it doesn't quite work for BC. In AB, indefinite integrals. If you see an ln, if you see an ln, somehow get it in the u. If you see an ln, somehow get it in the u. We have absolutely no derivative rule in AB, and BC you have to go through this kind of complicated process to get there. We have absolutely no integration rule for an ln inside. So if you have an ln, color pen it. Make it u. So if u is ln of x, let's see how it works, because some of your brains might not have figured out how it worked from the beginning. What would du be? What are we supposed to solve for? So I can take this, and I'm going to come back to the definites in just a second. So I'm going to have u over x times x d. What happens? Which leads me to 1/2 u squared. No plus c, because what am I doing? Ooh. Okay, I have options. Yeah, it's definite. Am I plugging in right now? Do I have u bounds? Or do I go back to x's? It's your choice. What would your brain do? Would your brain change these to u's and then just plug in right now? Or would your brain go back to x's and then plug in? Okay, so then I'm going to go ahead and say x equals e to x equals, oh, sorry guys, e cubed? Okay, so I have to go back to x's. X's don't belong in the u spot. Beware. Do a watch out. Okay, got to be careful when you do u sub. But now we can go ahead and say, okay, it's 1/2 of ln of x squared. Just a few of you who like doing shortcuts might have tried to bring that squared down from log properties, but it's not ln of, it's ln of x. Squared property only works when the squared is inside the argument, so technically it's illegal to do that property. So I'm going to go ahead and plug in and do a big old 1/2 with ln of e cubed squared minus ln of e squared. And didn't we talk about the other day what ln of e was? Isn't he 1? ln of e is just going to be 1. Oh, but how about ln of e cubed? 3, because a 3 comes down, then a 1. So that's going to be 3. So I'm going to end up with 1/2 times 3 squared is 9 minus 1 squared is 1. 8/2 ends up being 4, I believe. What else do we have? 9. Keep me going. This is awesome. I'm loving the pacing. Okay, let's do 7 then 9. 7. Doesn't 7 look like that fraction, dude, we just did a second ago? So couldn't we set u equal to x squared plus 1? Whole thing. Oh, sorry, minus 1. I can't even see signs. But why is that a bad idea? Do you see? If I put in a du over 2x, that doesn't cancel. Well, that's a bad idea. Okay, so it would have been a great idea in another problem. It's just not a good idea here. So guys, look at this guy. What else could we do? Factor? I like it. Doesn't happen very often, but when it does, we get very thankful. Because if we factor, now can't we just say u is equal to x minus 1 because I have 1 over u? du is super nice and easy because it's just 1 dx, so I can change this to 1 over u du, which is, that's an ln of u, which was x minus 1 plus c. But in number 9, well, it's actually a very similar idea because number 9, wouldn't some of you at least have thought of making the whole denominator u? I would have, probably, at some point. Sorry, I've been speaking the language for too long. But u equals 1 plus e to the 2x. But when you do du, do you guys see? It would have taken you guys a little bit of time to maybe I'd do it mental math, you would have done it here. If I divide, that's not going to cancel, is it, guys? Well, maybe that wasn't a good idea. Oh, so let's factor like this. I can't factor. That's a plus with a squared. A squared? E to the 2x isn't squared. Yeah, he is. He is? Isn't multiplication of powers the same thing as a power to a power? Does that change anything if you guys see this as 1 plus e to the x squared? 1 plus u squared? Is that an integration thing? 1 over 1 plus u squared? Maybe u is just the e to the x, and if u is the e to the x, du would be the e to the x dx, which would work out quite nicely for what I want, because when I go to plug in, I'll have my 1 plus u squared e to the x with a du over e to the x. That cancels out. What integration rule is 1 over 1 plus u squared? Arctan. So I'm going to do tangent inverse of, isn't it 1 over a, but who's my a? A squared, that's just 1. Tangent inverse of u over a, u is e to the x over a plus c. Tricky, 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 tricky. But did you see my brain taking it one step at a time? Try this. No? Well, that could be written like that, and then maybe. Or I think when AJ and I were talking about this one yesterday, because it's kind of nasty, I was like, well, if the whole bottom isn't it, maybe work backwards and be like, I need this e to the x to somehow go away. Well, hold on. At e to the x, I worked backwards with AJ, which might have helped or might not have. But e to the x, if I need that to go away, well, then I must have had an e to the x. Well, how on earth could e to the, well, I guess I could rewrite that as a, there are different ways of strategizing and playing with it. But anyway, that's what I would do. What else do we have? 11? Ha, 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 ha. Tell me what your brain sees. Tell me what your brain tried. Rewrite? We could have distributed this in, I guess, right? But we couldn't have brought that all the way in, true? Because he doesn't have a square root and he does. This would have been x times the square root of x minus 3 and 2 plus the square root of x minus 3. I think either way, though, if you write it, wouldn't you still be stuck with, I think u is x minus 3? Did anybody think of that? Like, it's stuck, it's underneath, right? What's my du going to be? Just 1, yeah. So, okay, what's weird then? Who doesn't belong? Come on, so what do? Go up here. Yeah, do you remember integration on crack? Crazy integration? Just keep going. Just keep going. I'm trying to think of a good analogy for this, and I probably should, and I think that might make integration on crack a bit more memorable. But off the top of my head, I can't think of it. I was thinking of something like if you're trying to do like a recipe, or if you're trying to like put together some sort of project, and if it's asking for a certain piece and all you have are like pieces that have been put together, and so you take them apart so you can go and put it in the recipe or put it in the... I was thinking of like nuts with bolts, but then that's not something that you guys would do. Is there any recipe I've ever... Yeah, I was thinking like for mac and cheese, like if I wanted to make spaghetti and then like extra people showed up and I'm like, I don't have enough pasta. I guess I could take the mac and cheese, which is all together, right? And then take out the cheese packets and be like, okay, oh well, here are more noodles, right? Or you could just take the cheese packets, and I don't know what you would do with that. That's kind of gross. But anyway. What am I doing? I need X. Okay, so go back. So go back and find something. People do that with ramen, like they just eat the noodles, or they just, I don't know.
I said Legos.
Oh, Legos? Oh, well, noodles works. I was stuck in the whole recipe thing. Legos. Oh, yeah, that's a great example. Because if you're trying to put together something and you already had something put together, you have to go back over there and then take it apart and find the piece you want. Oh, I'd always do it with wheels. I'm like, I already used wheels. I'll go steal my wheels. Anyway, coming back. There's never enough wheels. Anyway.
Yeah, me too.
Here, X. Go find him. He's right there. Okay, plug him in. It's not as dire as you thought. U plus 3 plus 2, wouldn't that be U plus 5? It's impossible. No, it's not. Can't I distribute now? And wouldn't that be u to the 1 and a half, or u to the 3 halves? And wouldn't that be u to the 1 half? I'm rewriting it because I'm going to have to use my power rule, right? Legos. So much more applicable. My noodles one I've actually done. Anyway. U to the 3 halves, 5u to the 1 half. Are we doing okay with the power rule, cool kids? Here's the dilemma. This one, if it was a multiple choice, which I've seen it be before, and you guys have seen it be before, they wouldn't have left it like this. Oh, I know. They would have taken the x minus 3 and they would have plugged it in. They still wouldn't have left it like this. So why am I taking all the time to come over here and get a custom pen, double check it's green, and underline? Come on. What's in common? Remember? Got to pull out what's in common. What's in common? I don't even have... Oh, yeah, I bet they would have done a common denominator of maybe 15ths. And then they would have tried to take out what's in common. I'm going to come over here to try to simplify. Why am I telling you this? Because this problem needed it? Nah, this problem was to stick it to the man, plug in x minus 3, and be done. This is never a long answer question. This is always a multiple choice type. I end up with 6/15 x minus 3 to the 5 halves plus 10/15 x minus 3 to the 3 halves. Sorry, 3 halves. What can I pull out that's in common? I see a 15th and I see a 2, right? What else can I pull out that's in common? X minus 3 to the smaller one. X minus 3 to the 3 halves. What's left? Well, I took away him, there's a 3. What happens when I take away powers? So I subtract. What's 5 halves minus 3 halves? 2 halves, which is just 1. Plus, I took away the 15th, I took away all of them, I took away a 2, and I have a 5. It's going to look so much different, because if you just take away that fractional guy, this guy will be nice. I end up with 3x minus 9 plus 5, 3x minus 4. I end up with 2/15 x minus 3 to the 3 halves, 3x minus 4. I would almost be willing to bet that if you come across some sort of question where you're getting lots of different fractional powers and you don't have time to simplify, go look for the nicest one. I would almost say that as far as if you ever had to guess. AJ. Times it by what? Oh, did I not do that? I didn't do that. So that'd be 2550. Which I can still only pull out a 2, right? So that'd be 25. So then -9, that'd be 16. The nice thing is, I bet at this point, that probably wouldn't have matched anything, so hopefully I would have gone back and looked. Thank you. I appreciate that. Why don't I have to? Oh, as in like the big old thing? Yeah. I was just being lazy and not writing it like all the way. Thank you. I was too distracted with the noodles and then the Legos and then the simplifying. Anyway, what else do we got? Yeah, 1 minus cosine squared? Yeah. Not a bad idea, it just doesn't work. No. Like, I almost did too, because I was like, oh, yeah, a cosine plus and a cosine minus. If it was a cosine of x minus 1 plus 1 or cosine of x minus 1 minus 1, that would have been great, because you could have factored and canceled like the one Thomas asked, or someone asked a second ago. Why is this one more basic? Because who's the derivative of sine? Times u prime. What's going to happen to him when I rearrange? I'm going to end up with u to the -2 du. So then all I have to do is a power rule, and then we're going to be able to solve. Is it okay if I stop there? Because now it's just a power rule. But you would solve for dx. Come on, guys. Please. I'm sorry. My brain does it fast. You know that. Solve for the dx. Do your system. You're going to cross out the cosines. It's going to be grand. Well, it's not. It's going to look like 1 over u squared du. What do you have to remember not to use? That's not ln. We have to rewrite that fractional power. Maybe that's something you put in the ln card or in the power rule card and say, watch out for negative exponents. ln's are only used. What else? 16? 15? Remember how a second ago I said if you ever see an ln in an integral, make it u because we don't have a rule? Guess who else fits in that category? Any arc trig, arc sine, arc cosine, arc tangent. They never belong in an integral. So if we ever see them, we always make them the u. I forgot this was the integration packet today. Good thing we didn't try to do corrections on the mock. Literally, it's a note. Make ln's and arc trig your u's. Always. There's this thing in CalcAB or CalcBC with this formula. Anyway, we have to choose. There's also this extra v dv thing. But at the very beginning, it's Liate is the little acronym. Is that the right word? Liate is a little word to remember, and L stands for logarithms, and I stands for inverse trig. Always make them u's. Why? Hey. This is a derivative practice. What's the derivative of arc sine? Oh, he's just that. Yay. So you can actually just go to u to u after you rearrange. Should be 1/2 u squared. I know I'm being horribly illegal because I have x bounds, right? I have x bounds. But I end up with 1/2 of arc sine squared from 0 to root 2 over 2. Why am I going and not just saying finish? Because I am afraid of some of your weaknesses with the unit circle. True? How do you do arc sine of something? Come on, that should be ding, 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 dinging all over the place, right? Isn't root 2 over 2 an actual sine value? I already heard pi over 4. Good. You have to go backwards with arc. 1, 2, 3. Sine is 1, 2, 3. 2 is in the middle at pi over 4. So it's going to be pi over 4 squared minus arc sine of 0 is just 0. times 1/2. And for right now, I'm going to stick it to the man. But it's going to be pi squared over 32, I believe. What else do we got? It's okay if you're done. You can have some work time. How many of you guys would think secant was your u? How many of you guys would think tangent was your u? The nice thing is, either way you cut it, it'll be just fine. What? If tangent was my u, what's the du of tangent? Derivative of tangent is secant squared. Don't forget your u prime. Oh! If I choose secant, well, okay, since most of your brains chose that, he's still possible, he's just trickier. If you choose secant, careful, it's not just secant of x, it's secant of 3x. Remember the little dude, calculus in 20 minutes? There was a blop, there was a Play-Doh, right? What was the blop for? What's the derivative of secant of blop? Secant blop, tangent blop times blop prime, chain rule. Secant of u, tangent of u times u. So if I go to plug in, a lot of you guys would have written the tangent. Then you would have said, yay, u squared, I got him from there. And then you would have written your dx over. And now all of a sudden you're like, oh crap, I have another secant. But that's okay. Do you guys realize that the tangents are going to cancel? The 3 can come out as a 1/3. What do I do with him? He's a u. Okay, fine. U squared over u du. Oh, wait, I can. Yeah, you can. You could have separated a secant to go with a secant tangent and then had another secant. Either way, though, it would work out. Sometimes you just got to go looking back to the beginning. Remember your Lego pieces? I know what I need. Go back and be like, someone. You. Literally, never mind. Not funny. So, equals 1/3 times 1/2 u squared would be 1/6 u squared. Who squared? Secant of 3x squared. What had you better remember? Your unit circle and how secant is the same thing as 1 over. It's because I'm thinking most of you guys will do better with 1 over cosine than you will with secant. I'm going to let you keep going. P.S. 3 times pi over 12 is pi over 4. That's unit circle. What else do we have? 18? 19? AJ's monopolizing.
I just don't know this entire thing.
Can I give you a hint? U is 1 minus x, and you got to think Legos. U is 1 minus x, and you got to think Legos. Because that du would just be a -1, but if you think Legos and go back and find an x and plug it in and then rewrite a bit. Well, wait a minute, guys. How do you rewrite when you have, we've done when you're multiplying, but we haven't done when you're dividing today. If I have my u to be 1 minus x and my du to be negative dx, so I plug in and get negative, and I come back and I get my x to be 1 minus u, I dismantle a little bit to get what I want. I have 1 minus u. There is no rule for this. We have to rewrite. How do we rewrite? I distribute this little guy to both. But how do I do this over this? That over that is just going to be him, which will eventually be u to the -1/2. But what do I do with this guy? I rewrite by subtracting the powers, right? So 1 minus 1/2 would be, just 1/2. Power rule. What else? 17? This isn't exactly like, exactly. This isn't exactly like if you see an ln, make it a u. If you see an inverse trig, make it a u. But this is if you see an exponential, make his power a u. And this is one of the rules that A, B, and B, C together hate the most. The integral of b to the u du. If we can even get here, which I know we can. You guys remember what it is? What's the integral of e to the u? Integral of e to the u. E to the u. So the integral of b to the u. B to the u. Ln of b is what you would get with the derivative, right? Boolimbu. So I have to take away the limb. If you take a derivative, it's boolimb. Boo. With the u prime. That's the u prime. The limb isn't there, so I have to divide by it. Like with a power rule. If the power brought down is not there, I divide by. But it's a rule. You got to memorize. You got to know it. They love to throw it in there just to make you get it wrong because you don't know the rule. But if I make my u, my du is going to be 1 over 2 rad x. Long story short, after you rearrange, you're going to end up with 2 to the u du in your integral. 1 over ln of 2. 2 to the is where you have to go to solve. You have to use your rule. You have to use your rule. What did I not do? I didn't do my dx is equal to 2 rad x du and then plug in. But then it cancels. All I get is this. And I use my rule. Anything else? 18? I see an exponential, do you? So who's your u? Which one? Not e. E to the u. B to the u. Right? Now do you see it? If u is x squared, oh, du is 2x. The x is going to cancel. Everything's going to be nice. Just be careful with this. What do you mean? Oh. The integral of e to the u is e to the u. You could do the ln of e, but this is still there. So we don't memorize this, even though it's technically the rule. We just go straight here. Yeah. Oh, you mean the plugging in part? Okay. When you plug it in, the square root squared. It's going to cancel, and then you're going to be able to go ahead and simplify. Kiddos, out of all the packets that you've had thus far, the trickiest as far as just mechanical skills is this one by far. The trickiest is this one by far, which is wasn't it also like one of your shortest ones? But how many think about your mock, and then as you take the other mock, I want you guys to be on the lookout for how many just plain old solve the integral questions are there. There are some, but there aren't tons. So don't let this totally crush your confidence. However, this is trying to show you they're going to give you a tricky one. We guarantee it for you to do by hand. They're going to give you 2 tricky ones. We guarantee it. What's it going to be? I don't know, but we're trying to do the best we can just to be ready. Does that make sense? What's LTF number 7 or number 8? I think you get to go back to matching and then maybe some separation of variables, which gives you so many points in FRQs. If you guys look at your FRQs and you see 5 X's, 4 X's, 6 X's in one question, what was it? A differential equation. Bye, guys.